Okay, now we have more simple equations. This time, rather than integers, we're dealing with fractions. So let's jump right into it. So we said our method here is to first use the commutative property if necessary to make sure that the variable comes first. So we're going to rewrite this first equation, and we're going to do two things. We're going to convert this mixed number into an improper fraction, and we're going to use the commutative property to switch the terms. So rewriting this becomes negative 39 tenths is equal to negative x minus, okay, so the negative 2.5 as a improper fraction is going to be 2 times 2 is 4 plus 1 is 5, so that would be minus 5 halves. All right, so now we ask ourselves, what is being done to our variable x? Well, the first thing that is done is we are multiplying by negative 1. All right, and the second thing that's being done is we are subtracting 5 halves. So to solve this equation, we go in reverse. So we're going to undo the last thing that was done to our variable. The last thing meaning the subtraction of 5 halves. And we're going to undo that using the complement to subtraction, which is addition. So we're going to add 5 halves to both sides of this equation. And this time I'll write it horizontally like this, or write it in line to show you that you can do it both ways. So plus 5 halves on the right and plus 5 halves on the left. All right, so on the right side, minus 5 halves plus 5 halves, these cancel out with each other, and we're left with negative x, or minus x. And on the left side, we're going to need to add these together by finding common denominator. So we already have a 10 here. We can see that our least common multiple is going to be 10. And we know that we need to multiply our denominator of 2 by 5 to make it into a 10, and so therefore we also need to multiply that numerator by 5 as well. And so what we get is 25 tenths minus 39 tenths, and that is equal to negative x, right? So then we just subtract the numerators there, so 25 minus 39 is negative 14, so we get negative 14 tenths is equal to negative x. And if we know that negative x also means the opposite of x, if the opposite of x is negative 14, then x must equal to, or is negative 14 tenths, then x must equal to positive 14 tenths, right? Or you could also think about this step as dividing both sides by negative 1. All right, so it's the same process, we just have fractions. Look at the next one, number 10. So first step, I want to rearrange this using the commutative property so that my variable comes first. So I'll rewrite it as follows. This will be negative x plus 1/2. Again, key step is that when you're using the commutative property, the signs stay the same. We're not changing the signs. So this is a positive 1/2, positive 1/2. This is a negative x, still a negative x. That's equal to 17 tenths. What's being done to our variable? Well, we're multiplying the variable by negative 1, and we're adding 1/2. So how do we undo the addition of 1/2? We subtract 1/2. So we will subtract 1/2 from both sides, like so. So on the left, we have the plus 1/2 minus 1/2 cancels out. That's just 0, and we're left with negative x is equal to, and again, we need common denominator. So we're going to multiply this 1/2 by 5 over 5. Right? Multiply the denominator by 5, multiply the numerator by 5. So this becomes 17 tenths minus 5 tenths. And so we get that negative x is equal to 17 minus 5 is 12. That's 12 tenths. So if negative x, or the opposite of x, is equal to 12 tenths, that means that x has to equal to negative 12 tenths. And that is it. Okay, the next one. X minus negative 3.5 is equal to 23/6. All right, so we can rewrite this as addition because we know that minus a negative is addition. So this is x plus, and then 3.5 as a improper fraction. 3 times 2 is 6 plus 1 is 7. That's 7 halves. So x plus 7 halves is equal to 23/6. what's being done to our variable? We're adding 7/2 to the variable. So therefore, to undo that, we need to subtract 7/2 from both sides. So minus 7/2, doing it vertically this time, minus 7/2. So on the left, we have x plus 7/2 minus 7/2. The 7/2 cancel out, we're left with x. So we get x is equal to 23/6 minus 7/2. So we need common denominators between 6 and halves. That's going to be 6 is the least common multiple. So we'll multiply the denominator by 3, and we'll multiply the numerator by 3. So this becomes negative, this becomes 23/6 minus 21/6. And so we get that x is equal to 23 minus 21. That's 2/6, which simplifies to 1/3. So x is equal to 1/3. And final one of this type, first step, we're going to use the commutative property to put the variable first. So this becomes b minus 1/2. All right, so b plus negative 1/2 or b minus 1/2. That's equal to negative 1. What's being done to our variable? We're subtracting 1/2 from the variable. To undo that, we're going to add 1/2 to both sides. So add 1/2, add 1/2. On the left, our 1/2s cancel out. Minus 1/2 plus 1/2 becomes 0, so we're left with just b. And on the right, we have negative 1 plus 1/2. And we could solve that, but we can just think about it using mental math and know that we're going to be left with a negative 1/2 for b. And that's our answer. Of course, we can check all of these by substituting our answer back into the equation and seeing if we get a true statement. And of course, now that we've done addition and subtraction, we're going to do multiplication and division. So here we have an equation, 8/39 is equal to 4/13 n. So the same logic applies. What is being done to our variable n? We are multiplying n by 4/13. So rewriting the equation, we can say this is 8/39 is equal to 4/13 times n. Now here, there are two ways we can think about this. We know that the complement of multiplication is division. So if we like, we can divide both sides by 4/13. All right, and that would look like this. So we're going to divide both sides by 4/13. And we've got this complex fraction thing going on. We have a fraction divided by a fraction. But another option that we can do is rather than dividing both sides by 4/13, we can multiply both sides by the reciprocal of 4/13. So let's look at that, what that would look like. All right, so just rewriting this first step over again. This is 8/39 is equal to 4/13 times n. And so the other option is that we can multiply both sides by the reciprocal of this fraction 4/13, which is 13/4. And so multiplying by the reciprocal looks like this. So this is 13/4. We're multiplying that side, and we're going to multiply this side by 13/4. All right. And what happens is on the right side, notice how the 13 and the 13 cancel, and then the 4 and the 4 cancel, leaving us with 1 times n, or just n. All right. So here we've got n on the right side. Here, of course, 4 goes into 8 twice, so this becomes a 1. But then 13 also goes into 39, so this becomes a 3. So this is 1 times 2, which is 2. 1 times 3, which is 3. So this is 2/3 is equal to n. All right? So this way you don't have to think about the compound fraction. But if you do want to do it using the compound fraction, you can still do it. So on the right side, 4/13 over 4/13 cancels out. On the left side, we have a compound fraction. So we have 8/39 divided by 4/13. So we can rewrite that as 8/39 divided by 4/13. And of course, we say that that is equal to n. And then to solve this, we use keep it, change it, flip it. So we're going to keep this first fraction the same. That's 8/39. Change it, change division to multiplication, and flip it. Multiply by the reciprocal of 4/13, which is 13/4. So essentially, we end up with the same thing. So the 13 goes into 39. This becomes a 1. This becomes a 3. The 4 goes into 8 twice, so this becomes a 1. This becomes a 2. And so this simplifies to 2/3 is equal to n. So we get the same answer. All right, so either way, you can do it. So let's look at number 14. So we're going to see that what is being done to our variable is the variable is being multiplied by 4/13 again. And so we're going to get rid of that by multiplying by the reciprocal of 4/13, which is 13/4. So let's just rewrite it here. So this is 28/65 is equal to 4/13 n. So we're going to multiply both sides by the reciprocal of 4/13, which is 13/4. So this is 13/4 and then 13/4 on this side as well. So on the right, 13s cancel, 4s cancel. That leaves us with 1 times n, which is n. And on this side, we can simplify as well. 13 goes into 65 5 times. And 4 goes into 28 7 times. So this becomes 7/5 is equal to n. All right, next one. What is being done to our variable? Our variable is being multiplied by 2. So rewriting the equation, we have -8/3 is equal to 2 times v. So here, since we don't have a fraction, we can simply use division if we want to, but we can also use multiplication as well. So let's use the multiplication by the reciprocal to show you that it works even if we have whole numbers. All right, so this is equal to 2 times v. So we're going to multiply both sides of this equation by the reciprocal of 2. 2 is 2 over 1, so the reciprocal of 2 over 1 is 1 over 2. So we multiply the right side by 1 over 2, or 1/2, and we'll multiply the left side by 1 over 2 as well. Okay, so again, we know that 2 is also written as a fraction as 2 over 1, so we can write this as 2 over 1, like so. And the 2's cancel, leaves us with 1v, which is just v. On this side, we're multiplying 1/2 times -8/3. 2 goes into 8 4 times, so that becomes -4, and we're left with -4/3, and that's our answer. 1 times -4 is -4/3, and then 1 times 3 is the third, so -4/3. And the last one, again, 4/13. That seems to be our favorite fraction for today. And so what we can do is multiply by the reciprocal of 4/13, which is 13/4, or in this case, let's go ahead and divide since we've been doing a lot of multiplying by reciprocal. So we'll divide both sides here by 4/13. And the reason we're doing that is because we know that this is 4/13 times p, and the complement of multiplication is division. So if p is being multiplied by 4/13, we can undo that by dividing by 4/13. So we're dividing both sides by 4/13. So we will have compound fractions, but that's okay because we know how to deal with those. So let's see, 4/13 and 4/13 cancel out on the right side, leaving us with 1p, or just p. And then on the left, we have a compound fraction, which is -20/39 divided by 4/13. We keep it, change it, flip it. We multiply by the reciprocal. So this is -20/39 times the reciprocal 13/4. And we know that 13 goes into 39 3 times. So this becomes a 1. This becomes a 3. And we know that 4 goes into 20 5 times. So this becomes a 1. This becomes a -5. And that's equal to p. So simplifying, we get -5 times 1 over 3 times 1. So that's -5/3 is equal to P. And that is how we do it.